guys, welcome back to Chapter 5, Bond Evaluation. Now in this session, let's talk about some of the timing characteristics of a bond. Now the first time characteristic of bond we have go over is the maturity term, or the term to maturity, or the years to maturity. It refers to the life of bond, and it also tells us how long can we collect the principal value. That's what maturity tells us. But it kind of ignores what happens within the maturity. So that is the, let's say, coupon payments. So in this way, we introduce a new time characteristic of duration. Duration considers both the repayment of capital at the end of the maturity. Duration also considers the size and the timing of coupons that happened within the maturity, or let's say before the maturity. So durations in this way actually provide us an indication of interest rate sensitivity. A higher level of duration means that this bond is more sensitive to a certain level of change in yield, and a lower duration means otherwise. Now, the interest rate sensitivity is not always a bad thing. If there is an increase in the bond yield, means that there will be a decrease in bond price to save us from the significant price drop in bond. So what we want to do is we invest in bonds that have lower durations, which means they have lower sensitivity to interest rate change. So that will save us from the significant price drop. Now, let's take another look at the interest rate change. If there is a decrease in interest rate, so that means the bond price is going to rise, and we want to fully explore that price appreciation. So bonds that have higher level of interest rate sensitivity is gonna have larger increase in bond price when there is a decrease in yield. So if a decrease in yield happens, we want the bond that has higher interest rate sensitivity so we can fully capture that price appreciation. So that is the trading strategy behind why we want to evaluate the interest rate sensitivity of a certain bond. Different levels of sensitivity are used for different interest rate change. Now, we have talked about the duration, right? The mainly two types of duration we cover in this session are the Macaulay duration and the modified duration. Macaulay duration has a unit of years, and modified durations is, well, it's applied when there's a very small change in yield. For example, 50 or let's say 100 basis point in interest rate change. The duration, we say, is a interest rate sensitivity measurement. So it shares many similarity with what determines the price volatility. Now, we know that higher coupon bonds have lower interest rate risk. So higher coupon bond would have lower Macaulay durations, which is measured in years. Now, we also know that the term to maturity, the longer the maturity is, the more sensitive this bond price is going to be to a certain change in yield. That means the maturity has a direct relationship with durations. Now, let's look at bond durations with greater details. Let me give you a definition of Macaulay duration. It actually tells us the weighted average time we need to wait until we recollect, or let's say re-fulfill, the investment that we have put down to buy this bond. So we need, let's say, how long is the time we need to wait until we have recollect all the investment that we have put down to this bond. Well, let's put it that way. If we are looking at a zero coupon bond, it means that the only cash flow we are going to have with this bond would be at the end of this maturity. So we would collect principal at the end of this zero coupon bond's life. So that in lines with the actual duration time, because that duration hits when we actually collect the payments. So that's why the zero coupon bond has a duration equals to its term to maturity, because the only cash flow that comes into our account happens at the end of the maturity. Well, for payments that has coupon when we buy a bond, obviously it shortens our duration because it accelerates the time that we need to wait until we have recollect all the investment we have put down into this bond. Now, we have said that the duration itself, it reflects our interest rate sensitivity. So it shares many features that interest rate sensitivity have with coupons and, for example, maturity. We say that a lower level of duration indicates a smaller sensitivity towards interest rate change. So that means high level of coupon, which presents lower interest rate risk, would lead to a smaller duration. So these two are actually negatively correlated. A high level of coupon indicates a lower level of interest rate risk and also a lower duration. There's actually a positive relationship between the maturity and duration because maturity is positively related, or it rises the interest rate sensitivity of a bond. So it also positively connected with the duration, which is a direct measurement of interest rate sensitivity. Lastly is the yield to maturity and duration is inversely related. Well, we can realize this function in our calculations or our, let's say, equation to calculate the durations. Now, let's look at some of the features here. For example, we are looking at the zero coupon bond and 3% coupon bond here. Both yields are equal to each other, both 15%. However, we can see that for a zero coupon bond, the duration is actually a linear function. And for the 3 coupon bond, even though these two bonds have similar level of risk because they have similar level of yields, the bonds that have coupon have a lower level of duration compared to the zero coupon bond, right? Now, let's look at this and this line here. Now, these two lines are both having 15% of coupons. Their durations is, much smaller compared to this one. However, we can see that the yield, this one is trading at 15% of yield, and that is trading at 6% of yield. The duration of this bond is actually much larger compared to the bond that have same coupon rate yet higher yield. Now, why is that? Let's look at the equation that used to calculate Macaulay duration. Like I said, Macaulay duration calculates the weighted average time. We need to wait until we recapture the value that we have put down to buy a bond. And it is measured in years. It indicates how many years we need to wait for, right? See, that's how we calculate this function. This D here refers to the Macaulay duration. The numerator here is the present value of the weighted cash flow. Now the weighted cash flow by what? By the time it received. Let me repeat. The numerator here is how we weight the coupon payments in the Macaulay duration. We weight these coupon payments according to its cash receipt. Let's see why the YTM is negatively related to duration. See, what is this function? This is the present value of the coupon. We weight the present value of coupon according to its cash receipt. Now, the present value of coupon is discounted by the yield. We discount future coupon payments to now, so that is the present value, right? So that means there is a negative relationship between PV and YTM. So let's enlarge that relationship. This means that the numerator here actually have a negative relationship with its yield, because PV has a negative relationship with yield. So the numerator is in a direct relationship with the value of the ratio, that is the value of the D. So that is why the yield has a negative relationship with D, because the yield has a negative relationship with the present value of the coupon. And the coupon appears in the numerator of the ratio, which have a direct relationship with D. So that's a negative relationship between YTM and D. Now, let's see a real example here to fully capture how to calculate Macaulay duration. We have 3-year bond, face value 1,000, 4% of coupon, and yield to maturity of 6%. The interest is paid annually. Let's first calculate the price of the bond. The first function gives us the present value of coupon. And because coupon comes in the form of annuity, so we can use a geometric proportion series to deduct a simple calculation using just one-time calculation here. And that is the present value of principal, which is repaid at the end of the maturity. These two parts of present value gives us the current selling price, or it is the price that we put down to buy this bond, which is right here. We need to calculate the numerator for the Macaulay duration. The numerator is calculated by the present value of the weighted cash flow. What weighted? Time weighted. Time weighted by what? By the time this coupon is paid. Well, we are assuming annual compounding here, so it means that we receive coupon one time a year, right? So the coupon payment is 4% times the face value of 1,000, so $40 a year. And we receive 3 times of coupon payments. Each happens at the end of the first, second, and third year. So that means the first coupon payments, which happened at the end of the first year, has a time value of 1, indicating it is paid by the end of the first investment term. And the second coupon, which paid by the end of the second year, has a time value of 2, indicating it is paid at the end of the second investment term. And the third payment is a payment of principal and the last coupon. It is paid by the end of the year 3, so by the end of the third year. So its time weight is 3, indicating it is being paid at the end of the third investment term. And we add them all together. Remember, it is timed with the present value of coupon payment. It is adjusted with the present value of the principal and the last coupon payment. So we weight these cash flows when they are using the present value. See? So that's the discount factor here, discount factor here, discount factor here. Don't forget to use the present value function for this calculation. Now, in this way, we have the numerator putting right here. So the next thing we want to do is using this numerator to divide the price of the bond, which is the amount of money we put down into these investments, which we have 2.8, well, let's say less than 3 years. It verifies our notion that a bond with coupon always have a duration less than its term to maturity. So it means that the investor needs to wait for averagely 2.88 years until they can recapture the investment value they have put down into that bond. So let me go over with the equation with you again. The numerator is giving the present value of coupon a time weight. That time weight is in line with the timing of the cash receipt, indicating that when it is realized or when it is paid. Now, that is how we use the Macaulay duration. The Macaulay duration can be used to compare bonds with different characteristics. For example, we are comparing two bonds. Well, the bonds have, let's say, they both have 3 years of maturity, but everything else is different. The yield is different, the coupon is different. We don't know which one to choose, but we do want to know which one is more sensitive to interest rate change, so we can take advantage of the change in interest rate. We can use the Macaulay duration to calculate their interest rate sensitivity. The one that has a lower value for duration having a lower level of interest rate sensitivity. And we want to have that investment when there is an increase in interest yield, because we want to minimize or to control the drop in bond price. If there is an decrease in the yield, it indicates that there is an increase in bond price, and we want to fully capture the bond price appreciation. So what we do is we buy bonds with high level of interest rate sensitivity to fully capture that increase in bond. Now, there's one key point about Macaulay duration that I need to stress. The Macaulay duration, even though it is measured in years, it is only a theoretical timing characteristics. It does not interfere with the timing in terms of when the coupon and the principal is going to be paid. Now, the payment of coupon happens at the end of each investment terms. And in our case here, the investment term is 1 year. So each coupon payment appears at the end of each year and at the end of year 3. So that is when the bond matures, we have collect the payment of principal and the last coupon payments. So the actual timing of the payments does not change. The duration itself is more likely to give us a feel out about how sensitive is a bond towards a change in interest rate. And that's it. It is more sensible timing issue because it is a more true reflection. Let's say a more comprehensive reflection for how the cash flows of bond are related to the interest rate change, because durations, it considers both the repayments of principal at the end of maturity. It also considers the timing and the size of coupon within the investment terms. So that's why it is a more comprehensive timing measurements compared to the term to maturity. And also we say it is a more true reflection of the interest rate sensitivity measurement because it captures the coupons. In this session, we have covered the calculation of Macaulay duration. And in next session, we are going to make a small reformation of the Macaulay duration, and we use that to develop modified duration, which is going to be useful when there is a very small change happens to yields. All right, looking forward to see you in our next video. See you next time.